Let's look at a few more examples of how to factor by grouping. Let's start by factoring the expression x squared plus 5x minus 4x minus 20. We'll look at both the way to do this visually and how to factor it algebraically as well. Let's start with the visual method. We'll need to draw a box with 4 spaces for each of our 4 terms. Then we'll write our 4 terms inside each box. So we have x squared plus 5x minus 4x minus 20. Next, we want to factor the greatest common factor from each row and each column. The greatest common factor between x squared and 5x is x. The greatest common factor between negative 4x and negative 20 is negative 4. The greatest common factor between x squared and negative 4x is x. And the greatest common factor between 5x and 20 is positive 5. So when we factor this entire expression, we get the quantity of x minus 4 times the quantity of x plus 5. Now let's try this out using the grouping method. For the grouping method, we want to split our terms into 2 groups. So we want to group together the x squared and the 5x, and we want to group together the negative 4x minus 20. So we have x squared plus 5x plus negative 4x minus 20. Then we want to factor the greatest common factor from each group. The greatest common factor between x squared and 5x is x. So we have x times x squared divided by x is x, plus 5x divided by x is 5. Plus, now we want to factor the greatest common factor between negative 4x and negative 20. The greatest common factor between these 2 terms is negative 4. So we have negative 4 times the quantity, negative 4x divided by negative 4 is positive x. Negative 20 divided by negative 4 is positive 5. After factoring out the greatest common factor from each group, we want to see if our products have a common factor. They do. Both of these products have the quantity of x plus 5 as one of their factors. So we can factor out that entire quantity of x plus 5. So we have x plus 5 times, starting with our first product, we have x times the quantity of x plus 5, then we'll divide out the quantity of x plus 5, and we're left with x. Next, we'll look at negative 4 times the quantity of x plus 5, divided by the quantity of x plus 5, leaves us with that negative 4. Then, rewriting the plus negative 4, we have x minus 4 times the quantity x plus 5. This is the same expression that we got using the visual method. But just in case we made mistakes both times, let's check our answer. We can check our work by expanding. Let's use the double distribution method. So we will distribute our first factor, the quantity of x minus 4, to each term in our next factor. So we have the quantity of x minus 4 times x plus the quantity of x minus 4 times 5. Then we'll distribute the x to each term in the x minus 4, and the 5 to each term in the x minus 4. X times x is x squared. X times minus 4 is equal to minus 4x, plus 5 times x gives us 5x, and 5 times that minus 4 gives us minus 20. This was the original expression that we had. So the quantity of x minus 4 times the quantity of x plus 5 is the correct way to factor the expression. Now let's look at another example. Let's start by using the visual method. So we'll take each term in this expression and give it its own box. So we have x squared minus 6x plus 7x minus 42. Then we'll factor the greatest common factor from each row and each column. The greatest common factor of x squared and negative 6x is x. The greatest common factor between positive 7x and negative 42 is 7. The greatest common factor between x squared and 7x is x. The greatest common factor between negative 6x and negative 42 is negative 6. So the factored form of our expression will be the quantity of x plus 7 times the quantity of x minus 6. Now let's look at this using the grouping method. So we'll want to split our expression into two groups. So we'll have one group, which is x squared minus 6x, and another group, which is plus 7x minus 42. So that gives us the quantity of x squared minus 6x plus 7x minus 42. Once you have your two groups, you want to factor the greatest common factor out of each group. The greatest common factor between x squared and 6x is x. So I have x times x squared divided by x is x. And negative 6x divided by x leaves me with minus 6. Plus, the greatest factor between 7x and negative 42 is 7 times 7x divided by 7 is x, and negative 42 divided by 7 gives me minus 6. Once you factor out the greatest common factor from each term, you want to look for a common factor in each of our products. Both of our products have this quantity of x minus 6. So we can factor out that entire expression. So I have the quantity of x minus 6 times x times the quantity of x minus 6 divided by the quantity of x minus 6 gives us just x, plus 7 times the quantity of x minus 6 divided by the quantity of x minus 6 gives us just 7. So the factored form of my expression is x minus 6 times x plus 7. These two expressions are equivalent, but let's check our answer by expanding just in case. So let's expand this. This time, let's use the arrows method. So we'll distribute the x to each term in the second binomial, and we'll distribute the minus 6 to each term in the second binomial. X times x gives us x squared. X times 7 gives us 7x. Negative 6 times x gives us minus 6x, and negative 6 times positive 7 gives us negative 42. This is equivalent to the original expression, so the quantity of x minus 6 times the quantity of x plus 7 is the correct factored form of our expression.